In this video, I want to look at divisibility test. And this is a method for checking or testing to see if some counting number is divisible by another counting number without actually carrying out the division. So I want a short way to see if one number is divisible by another without actually fully performing my division. And there are several divisibility tests for numbers less than or equal to 10. So I want to look at each one of these divisibility tests individually. Let's start with the divisibility test for 2. The divisibility test by 2 says the number is divisible by 2 if the ones digit is either a 0, 2, 4, 6, or 8. And I'll talk about this divisibility test a little bit more in my next video when I talk about even and odd. So this tells me if I look at numbers like 379, this would be not divisible by 2. Since it ends in a 9, however, 462 is divisible by 2, since it ends in a 2, which is on this list. Next, I want to look at the divisibility test for 10, which is another one of the easiest tests. The divisibility test for 10 says a number is divisible by 10 if the ones digit is a 0. And if the ones digit is not a 0, it's not divisible by 10. So if I look at a number like 478, it would not be divisible by 10, since it does not end in a 0, but 620 would be divisible by 10. So the reason this divisibility test by 10 works is because if you multiply a whole number by 10, it just adds a 0 to the end. So we look for the 0 at the end to determine if we can divide evenly by 10, since dividing by 10 would remove that 0. Next, let's look at the divisibility test for 5. The divisibility tests for 2, 10, and 5 are the 3 easiest to understand, so we're going to start with these. A number is divisible by 5 if the ones digit is a 0 or a 5. As an example, 372 would not be divisible by 5, but 645 would because it ends in a 5. And the reason this works has to do with how we count by 5s. Every 5 increases me up to 5, 10, 15, 20, 25, 30, etc. Multiplying by 5 always results in the last digit being either a 5 or a 0, since that's how we would repeatedly count by 5s. Next, let's look at the divisibility test for 3. My divisibility test for 3 is a little bit different. For this one, we need to add the digits of the number. If the sum is divisible by 3, then the original number is also divisible by 3. As an example, let's look at these two numbers here. 127,358. Well, 1 plus 2 is 3, 3 plus 7 is 10, 10 plus 3 is 13, 13 plus 5 is 18, and 18 plus 8 is 26. So if I add up the digits here, I get 26, which is not divisible by 3. If I add up these digits, 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 1 is 5, plus 1 is 6. That is divisible by 3. So this number on the right would be divisible by 3. So the divisibility test for 3 is very different than those for 2, 10, and 5. So why does this work? Why is this a valid way to determine whether a counting number is divisible by 3? In order to think about this, let's think about the number represented in base 10 blocks. The number will be divisible by 3 whenever those base 10 blocks can be divided into groups of 3 with none left over. So we have to consider dividing our base 10 blocks that represent our counting number into groups of 3. So in order to do this, I could start by dividing each of my 10 blocks, each of my 100 blocks, each of my 1,000 blocks, etc. into 3. So let's take a look at that. Let's start with my base 10 rod, which is here. So this has 10 blocks total. So this right here would represent my number 10. And we can see that this can be broken into 3 groups. We have one group here, one group here, and one group here, and then we have one left over. So if we want to break these up into groups of 3, we can do that 3 times. We have one left over. Similarly, every 100 block can be divided into 33 groups of 3 with one left over. Each bundle of 1,000 can be divided into 333 groups of 3 with one left over, etc. So from each place, from the tens place on up, every block will be equally divided into groups of 3 with one left over. So the idea is we're going to collect all of these. If we had something like 40, we would break each of my 10 blocks into these 3 groups of 3, and we would have 4 left over at the end. So we want to think about how many of them do we have left over at the end. Well, let's think of a number like 248. From the 200s, we would have 2 left over. From the 4 tens, we would have 4 left over. And from the 8 ones, we would have 8 total ones. So now we have a total of 2 ones, 4 ones, and 8 one blocks. Once we combine all of these little one blocks, we would have a total of 14 one blocks. We would have a total of 14 little individual blocks. And so we only need to look at this and see if this is divisible by 3. Since this is how many one blocks we'll have after we've already grouped our 100s and our 10s into groups of 3. And in this case, we could see that it would not work. We would have 4 groups of 3 and 2 left over, which would not work. So this is the idea, is we are breaking these up into pieces, and the digit actually tells us how many extra blocks we would have once we've broken those blocks up into groups of 3. Next, let's look at the divisibility test for 9, which is very similar to the divisibility test for 3. For 9, if the sum of the digits is divisible by 9, then the number is also divisible by 9. So this is very similar to my test for 3. And to see why this is the valid way to see if a number is divisible by 9, we can use the exact same argument we did for the divisibility test of 3. Instead of breaking up my blocks into groups of 3, we need to think of them as breaking up into groups of 9. And we can still see that we'll have one left over from a 10 block, one left over from a hundreds block, one left over from a thousands block, etc. So far, we've talked about our divisibility tests for 2, for 3, for 5, for 9, and for 10. There actually is not a nice divisibility test for 7, so we only have 3 left, 4, 6, and 8. Let's start with the divisibility test for 4. A number is divisible by 4 if the last 2 digits are divisible by 4. As an example, 562. If I want to look at 62 divided by 4, this is not a whole number, so this would not be divisible by 4. However, 96 divided by 4 is a whole number. It is 24. So yes, this would be divisible by 4. So now we have our divisibility test by 4, and we only have 2 left. Let's start with the divisibility test for 8, since it is very similar to the divisibility test for 4. A number is divisible by 8 if the last 3 digits are divisible by 8. So for 2, we only need to look at 1 digit. For 4, we need to look at 2 digits. And for 8, we need to look at 3 digits. So now that we've discussed 8, we have one final test, the test for 6. The divisibility test for 6 says it needs to be divisible by both 2 and 3. So it needs to pass my divisibility test for 2, as well as the divisibility test for 3. And this is the result of 6 being equal to 2 times 3. So this determines that it must be divisible by both 2 and 3 in order to be divisible by 6.